Okay, welcome back. This is part 4 of the lecture. Let's just kind of review where we are here. We're talking about this skeptical possible argument here that says how can you make a forecast of the weather 100 years from now if you don't know anything about the weather 3 or 4 days from now? This is our straw man argument that we're sort of picking apart here. And our first part of the lecture has been about how this question, this argument reflects the fact that the skeptic doesn't understand that weather forecasting and climate forecasting are two very different types of questions. Now we're going to say that there's a second way in which this argument doesn't really work, and that is that the skeptic doesn't understand that questions of climate and questions of weather have two very different kinds of answers. What constitutes an answer for a question about weather is very different than what constitutes a question about climate. So, like, for example, if you want to know something about weather in the coming days, what is a good answer to what the weather is going to be like 3 days from now? What do you mean when you ask what the weather is going to be? Well, what you're looking for here is specific information about weather conditions. You're not saying, I just want to know if it's warm. You want to know it's going to be 75, or you want to know the chances of rain or something like that. And you don't mean globally. Nobody's ever asked what the 3-day forecast for the global temperature is. You mean at a specific location. You mean also at a specific time. If you're asking about the weather 24 hours from now, that is different than asking about the weather 48 hours from now. All of this also needs to be very accurately. Saying that tomorrow the temperatures will be in the 80s when it's really in the low 90s is a busted forecast in some ways. And you know what? This whole business of making forecasts with meteorologists and numerical weather prediction models and so on works for about 4 or 5 days out from the start of your forecast, and sometimes a little more, sometimes a little bit less, but certainly not like 100 years out into the future. But here's the deal. Who cares? Who cares what the weather's going to be doing 100 years from today? That's not really the answer I'm looking for. The climate scientists don't need to know what the weather is going to be like 100 years from today. We have different things constitute an answer when we're talking about a question in regard to climate. If I have a question about the climate 100 years from now, I mean things like, what is the global mean temperature 100 years from now? Not necessarily like right there where, in Omaha or something like that. We mean over long periods of time. I don't really care what the weather is going to be doing on January 1st, 2200. I mean, like, what is the climate like in the first decade of the 22nd century or something like that? Okay, I'm just talking about over broad periods of time. I'm looking for broad patterns of the weather. Are droughts more likely? Are the tropics expanding? What's happening to the ice sheets? Things like that. And frankly, trends are good enough. If I know that it's getting warmer, it's not going to be hugely important to me whether the amount of warming is 3 degrees Celsius or 4 degrees over the next 150 years, okay? I'm going to get the sense that probably slightly different simulations are going to give slightly different answers anyway. I just mainly want to know the trends when I'm talking about climate. So, like, if I want to run a climate model, I can run the model out for maybe 100 years, and it works like a numerical weather prediction model. It is making a prediction about every 15 seconds or so and it just repeats that process thousands and thousands and millions of times as this numerical model of climate runs for literally like weeks or months on a supercomputer to make a forecast for, say, 100 years out into the future. But, after about 3 or 4 days into the model run simulation, the forecast, we're not correctly predicting any particular day. Rather, what we're saying is we're just going to take like the average of the first simulated 10 years of the run and, take the average global temperature. We're going to say that's kind of what the model thinks our current temperature is globally. And then we'll take like the last 10 years of the model simulation and compute the global temperature during that last 10 years, understanding that there's warmer years and colder years and so on, all being averaged out in there to find the future temperatures in some future situation, and the difference is going to tell us how climate changed over the course of that 100-year simulation. It almost pains me to say it, but in some ways the skeptic was right. We can't forecast the weather 100 years from now, but that's not the question. Climate scientists don't care about weather. Climate scientists care about climate. Not one of the individual days of the forecast that is being, produced by the climate model is right. But the climate and the patterns of weather and so on, the global climate, are going to be well simulated. All right, now, what's going to happen here is when you segue over to part 5 of this lecture, part 5 was recorded at a different time, and it is about a different way to think about initial and boundary condition problems in the context of Vegas casino games. It's going to help you understand this idea that we can have things that are more or less predictable depending on whether they're initial condition or boundary condition problems. But before we get there, let's talk a little bit about some questions here. Before you segue to Unit 5, let's do 2 questions here. Question 7. When climate scientists predict changes that will happen in the next 100 years due to anthropogenic greenhouse gases, they're actually forecasting A, the politics of how mankind will continue to burn fossil fuels, B, trends in global mean temperature, or C, the actual weather 100 years from today at your location. Alright, take a look at those 3 answers and make your choice. Get a little feedback before you move on to question 8.